You already know what is reflection and what are the properties of reflection. The distance from the object to the mirror is same as the distance from the mirror to the image. Now you also know why do we use a graph paper? It helps us visualizing things in a precise manner and get accurate measurements of it. Now let's try to put these reflections on a graph paper and see if we get accurate measurements. Now you can see, as we had put this image, that this X line is acting perfectly as a mirror line for this person, so that she can see her image beyond the X-axis. Now let's try reflecting a point on the X-axis here. Now we have placed a candy, say on the point P. Now we do not know the X coordinates and the Y coordinates of the point P. Now you can tell me that, as we have already placed the point P, tell me the X and the Y coordinates of the point P. Well, you can see that there are 2 points on the X-axis and 1, 2, 3 points on the Y-axis. So what is the X coordinate? It is 2. And what is the Y coordinate? It is 3. So you can write point P as 2, 3. 2 is the X coordinate and 3 is the Y coordinate. Now let's do reflection. We have taken the X-axis as its mirror line. So this is the object, this is the mirror line. So we'll get the reflection somewhere here. Let's see where we get the reflection. See, we are getting the reflection as P dash. So this was the object P and we got the image as P dash. Now how did we get it so exactly, like accurately? Let's see. Well, you can see that the image P is 1, 2, 3. That is 3 units from the X-axis or the 3 units from the mirror line. In the same way, the image is 1, 2, 3. That is 3 units from the X-axis, 3 units from the mirror line. We know that the distance of the object from the mirror line is same as the distance from the mirror to the image. So we got the reflection of P as P dash. Now one more thing did you notice? That the coordinates are changing. Well, the X coordinate does not change as this is a straight line. So X coordinate will not change here. It remains 2. Now the Y coordinate is changing, but only the sign of the Y coordinate is changing. See, first we are having 3, here we are having -3. So only the sign of the Y coordinate is changing. That is also why, because of the quadrant, we know that in this quadrant, that is quadrant 1, y is positive, and in the quadrant 4, y is negative. So because of the change in quadrant, we are getting a change in the minus sign. That is, change in the sign of the Y coordinate. So what did we learn? Whenever we reflect a point through X-axis, that is, X will act as the mirror line, then X remains constant. That is, the X coordinate will remain constant, but the sign of Y changes. That is, the sign of the Y coordinate will change. Here it is 3, here it is -3. Only the sign will change. Now suppose it would be -3 over here. What it would be here? We'll change the sign. We'll change the sign from minus to plus. So it would become only 3. Now you would be thinking that can a y-axis act as a mirror line? Well, yes. Let's see how. Here what we have done, we have placed the candy where it was, that is at the point 2, 3, and we have considered this y-axis as the mirror line. Now where will we get the image? Well, you can see that the point P is 2 units. See, 1 and 2. 2 units from y-axis. 1, 2. So the image will also be 2 units from the mirror line. Like this. This is 1, 2, 2 units from the y-axis. In the same way, this is also 1 and 2. 2 units from the y-axis. So distance from the object from the mirror is same as the distance from the mirror to the image. Now what about the signs? Let's see. You can see that here y coordinate is same. We are reflecting from the y-axis, so y coordinate is same here. It is a straight line, so y coordinate will be same as we had learnt in the chapter of plotting lines. And the sign of the x coordinate is changing. See, here we are having 2 because this is 2. Here we are having minus 2 because the x coordinate here is minus 2. So you can see that the sign of the x coordinate changes whenever we reflect a point on the y-axis. So remember, whenever you reflect a point about the y-axis, y coordinate will always remain constant. It will remain same while we'll change the sign of x. The number will be the same, only the sign will change. Now solve this question. Find the coordinates of the reflection of the point P, which is 3, minus 7, when it is reflected about x-axis and then y-axis. Do it yourself. Now, when we reflect a point about the x-axis, what have we learned? X remains constant while the sign of y changes. We are talking about the coordinates. So when we will reflect this point on the x-axis, we'll do without the graphs. We'll just write, say P dash is the reflection of this point. What will be the coordinates? X remains constant. That means x coordinate will be the same. What about y? We have to change the sign of y. Here the sign of y is minus 7. So when we change it, we'll get only 7. Right? Now what about when we reflect this point on y-axis? You know that whenever we reflect a point on the y-axis, y remains constant while sign of x changes. So this is about the coordinates. Let's write the reflection, say P dash. What about x coordinate? Yes, the sign will change. Here it is only 3, so we'll change the sign to minus 3. And y remains constant, so minus 7 will come exactly like the question. So this is the reflection of P on y-axis. So what did we learn today? That whenever you reflect a point about x-axis, x coordinate will remain constant while only y will change its sign. And when you reflect a point about the y-axis, y will remain same while the sign of x will change.